But yesterday we talked about hyperbolas. What's the major difference, other than the way the graph looks, but what's the major difference in the equations between a hyperbola and an ellipse? What's that big difference? Yep. An ellipse has a plus sign in the middle, and a hyperbola has a minus sign, right? It's the only difference. The graph looks different, yes. But we also talked yesterday, I don't know if we actually physically wrote this down, but I want to make sure that we write down and understand exactly what these letters mean. You have three different letters. You have an A, you have a B value, and you have a C value, correct? In your ellipse and your hyperbola, both of these are the same things. You need to know what these numbers represent. A is the distance between what? Between the center and the vertices, or the vertex. All right, that's important to know. Could be up or down, could be left or right. What is the C value? It's the distance from where? Distance between, good, center and your foci, focuses. All right, your hyperbola has two focuses, which mean foci. So those are on the same axis. These two are on the same axis. They're both on the major axis, the one where all the good stuff is. What is that B value? B is the center, the distance, can't spell, between the center, good, and the co-vertices. Now, I don't really mean this, so no one take offense to this, but who's more important, the captain or the co-captain? Captain, right? I don't really mean that in real life, but in our thought process. So on the main transverse, the axis that carries all the information, that's where your vertex and your center and your foci are. The other axis is where the co-vertices are. And we didn't talk much about that yesterday. We talked about how to find, if you know A and B, how to find C. If you know B and C, how to find A, that sort of a thing. Just using that formula to manipulate. But understanding what that actually is, you guys have asymptotes. Remember from graphing, when we did sine and cosine curves and stuff like that, we did rational functions. We had asymptotes, where your graph gets really, really, really close to, but doesn't do what? Doesn't touch it. It's just a boundary line. So if you notice here, if you plotted, look, here's my center, right? Here's my vertices. I'm sorry, here's my co-vertices. And here are my vertices, the important stuff, right? This is what kind of a hyperbola? Is this a vertical one or a horizontal one? Which way is it opening? Left and right or up and down? It's opening left and right. So it's a horizontal. So your co-vertices are on the vertical axis. But if you notice here, guys, if we were to connect our co-vertices and our vertices, do you see the square? Sometimes it's a rectangle that is shaped, that forms in the middle here. Yeah? Right? That will always happen. It's always going to be a square or a rectangle. These are your asymptotes. Your asymptotes define the shape of your hyperbola, whether it's going to be wide, whether it's going to be real thin, whether it's going to be slanted, funny. But these are just equations of lines that give you the shape of your hyperbola. They always meet in the middle, and we'll figure out a way to find them. It's a very simple process, I promise. I just want you guys to understand. Your asymptotes are two lines, they're boundary lines, I should say, that meet, they intersect in the middle, but they form the shape of your branches of your hyperbola, whether it be like a real skinny one or whether it be real wide, something like that. That's what your asymptotes are, the boundary lines that help you draw it. So here are the equations of the asymptotes of a hyperbola. And you guys, at first, you're like, what? Okay, look at this. It's an equation of a line. Y equals what? Mx plus b, correct? Look at these two equations. Are they similar? Yes. Are they a tad different? Yes. But notice you have an H and a K. What does your H and your K represent? That's the center. So in both of them, you use the H and the K in the same spot. Both of them have a Y equals and an X inside a parenthesis. Those always stay as Y's and X's. The only thing that changes is this value out here. And if I were to compare this value out here to a value that's inside of my equation of a line, what do you think that a over b or the b over the a is the same as in the equation of a line? Well, just in terms of here, from from these two equations here and to this equation here, what do you think that a over b is the same as in the y equals mx plus b? It's the same as the slope, okay? That is an extremely important thing for you guys to put together. All right, we're going to use that in a second. So how do you figure out which equation you use? Well, if you have a horizontal transverse, meaning your transverse goes left to right, so that means your branch is open left to right, you use the top equation where you take your b value and put it over your a value. If you have a vertical transversal or a transverse axis, that means your hyperbola opens which way? Up and down, then you use the bottom one. Does that make sense? The only difference, guys, is if you put the b over the a and the a over the b. So if that's where you make your little mistake, that's not a little mistake. That's a big mistake, right? So we're going to do two examples to kind of look at this and compare, and then we're going to be done. Now, this is from yesterday. I rewrote it a little prettier, but we did this one yesterday. You guys, we did this together. All right, so we put the equation in standard form. You guys agree with me? This is all the stuff that we found here. I just rewrote it, so we didn't have to do it again. We have our equation in standard form. We have the center, the AB, and all that stuff. So this question asked us to graph and find the asymptotes. So let's do a little sketch here. With what we have, let's just do a little sketch. First thing that's important to put on your graph is what, probably? The center, okay? So 1, 2, 3, 4, 2. Now, if there's not a picture, you guys should always draw one. It's very helpful. So your center is at -1, 0. That's my center. Now, I know that the A value tells me how far my vertices are from the center. And I know my C tells me how far the foci are from my center. But I don't know right off the bat if I'm going up and down or left and right. How can I tell from the center if I'm going up and down to get my major points or left and right, given the equation that we found yesterday? What kind of a hyperbola is this one? Why is it vertical? Because y is what? First, right? Y is first. So I know that, ooh, this is a vertical one. That means all the important information is on that vertical transverse axis. So A is the distance from the center to the vertices. So from the center, I'm going to go up to find one vertex, and I'm going to go down to find the other vertex. Does everyone understand that? All right, your C value is your foci, because remember, your branch is open towards the foci. So square root of 7, you guys are like, I don't know where that is. Well, it's in between the square root of 4 and the square root of 9, which is in between what two numbers? Square root of 4 is 2, square root of 9 is 3. So you're going to go from the center and you're going to go 2-ish up, and you're going to go from the center and go 2-ish down, and that gives you your foci. So now we have kind of a general picture of what our hyperbola looks like. I know that it's a vertical. I know my branch is open towards the foci, and I know where my center is, right? So something like that. Why is that important to have a visual in your mind if you're trying to find the asymptotes? Because if I go over here and I look at the equation of the asymptote, how do I figure out which one I use? How do I know which equation to use? I'm going to do the one that's vertical because my hyperbola is what? Vertical. So I'm going to write down, okay, y equals k plus or minus a over b times x minus h. So the three values I need to write my equation would be the h and the k, which is the center, correct? I need an a value, and I need a b value. Do I already have those things from what we worked out yesterday? Do I know what the center is? What's your center? It's, what is it? -1, 0, okay. What's your a value? 2, and what's your b value? Square root of 3. Okay, this is from yesterday, guys. So A is 2, B is square root of 3. All you do to write the equation, guys, is plug that information in. So I have y equals, my k value is 0 plus or minus, what's the A? 2 over B square root of 3 times what? X minus a negative, so plus 1. If you guys left your equation like that, that's totally fine with me. If you want to go ahead and say, okay, it's y equals 0 plus or minus 2 root 3x plus 2 over root 3, that's fine. Don't worry about rationalizing. Either one is fine. But the biggest thing, guys, is this. Is it A over B or is it B over A? And that's all dependent upon if you have a vertical, excuse me, a vertical hyperbola or a horizontal hyperbola. Does that make sense? All right, so I'm going to do another example here. Let's move along to this one. It says, find the standard form of the equation of a hyperbola. Okay, so I already know. They told me it's a hyperbola. So I'm going to do the x minus h squared over a squared minus y minus k squared over b squared equals 1. Or y will be first. I don't know that right now. How could I go about starting to figure that out? What can I do? Draw it, okay? Let's draw what they gave us to see what we're looking at. 2, 3, 4. There's not going to be a picture, guys. You need to draw one. So I have two vertices. I have one at 3, -5. So 1, 2, 3, -5. That's a vertex. And I have one at 3, 1, 2, 3, 1. All right, so I have to write my equation. To write my equation, I know I have to have the center, I have to have an A value, I have to have a B value, right? If I have two vertices, how do I find the center? The midpoint, okay? So my two vertices are at 3, -5, and at 3, 1. So the midpoint of those two will be my center. So to find the midpoint, do you guys agree with me? We're going to say 3 plus 3 divided by 2 and -5 plus 1 divided by 2. Yeah? Okay, so my center's at 3 plus 3 is 6 divided by 2 is 3, comma, what's -5 plus 1? -4 divided by 2 is -2. All right, I have my H and my K. I have my center. Awesome. Now, the other two values I need are my A value and my B value. Remind me again, guys. Let's plot our center. So it's at 3. 1, 2, 3, -2. That's my center. What kind of a hyperbola do I have here, y'all? I know it's vertical. Look, all the major information is along a vertical line, correct? So what is the A value? Remind me again what A represents. The distance from where? Center to vertex. Can we figure that out by the information they gave us? Yeah. How far is it from the center to one of the vertices? Doesn't matter, up or down. It's 3 units, right? You guys agree? What is the B value? Distance from where? Center to co-vertices. Well, I know since all of my useful information is on the Y, up and down, my co-vertices are on the X. Do I know anything about that? No, I don't have any points I can plot to count, so let's think about it. I have the H, I have the K, I have the A. The one thing I'm missing is the B. But they gave me a piece of information right here that is so super important. They told me the equation of the asymptotes. Did they not? They told me one of the asymptotes is y equals 2x minus 8. And they told me one of them was -2x plus 4. Why is that helpful information? Think for a second. Do we, first of all, okay, the equation of my asymptote. Do we know, guys, what kind of asymptotes I have? What kind of a parabola are we dealing, or a hyperbola are we dealing with again? A vertical one? So what's the equation? Y equals K plus or minus what? For a vertical? A over B times x minus h, correct? Tell me. What did you guys tell me the relationship was between the slope and the a over the b or the b over the a? They're the same. Now, some of you are like, well, wait, one of them is 2 and one of them is -2. All right, let me show you what you can do here, guys. Those are the same things. So what can we do with these two? We can set them equal to each other. I'm going to say 2 over 1 equals a over b. And I'm going to do it over here using -2 over 1 equals a over b. I'm going to show you why you can use either one. If I were to solve this, all right, 2 over 1 equals, do we know what our a value is? It's 3, so 3 over 6. Sorry, just kidding, 3 over b. I can't even read my writing. How do I solve this now? How do you solve a proportion, guys? Cross multiply, so 2b equals 3. So what does b equal? 3 over 2, correct? Agreed? Okay, so I'm going to come over here, do the exact same thing. I'm going to cross multiply. So I have -2 over 1 equals 3 over b. And then I'm going to say, okay, -2b equals 3. So b equals -3 over 2. Why does it not matter if I use the positive one or the negative one? Okay, because we're going to distances. Good. Very good. All that's saying is I'm going one way. I'm going left to a covertice. I'm going right to a covertice. Very good. What's another reason it doesn't matter? You guys told me that this is a vertical hyperbola, right? So I'm going to start off with y. And then I have... You guys agree? All right, so let's fill in the information we found out. What was our center again? My center was at 3, -2. So if I'm going to fill in my information, I have y minus the negative is going to give me +2, correct? Squared. Over, what was my a value? What did we figure out a was up here? 3, and 3 squared would be 9, okay? Minus, okay, so I have x minus 3, you guys agree, squared, equals, well, I have a b value. I have one b value as +3 over 2, and I have one b value as -3 over 2. Guys, when you take 3 over 2, whether it be positive or negative, and you square it, what kind of a number do you get? Positive. That's why, again, there's 2 reasons. It doesn't matter because you're going to square the a or the b value, and it's going to be positive anyways. But like Ava told us, all it is a direction. That negative is just a direction, whether it be left or down. So this becomes 9 over 4. If you guys got to this point and left your answer like this, I would give you credit. I got to look at WebAssign. I'm not sure exactly how they take it. The most correct way would be to write y plus 2 squared over 9 minus, what do you think goes in front of the x minus 3? 9. The 9. So 9x minus 3 squared over 4 equals 1. That's the most correct way to write it, but if you left it with 9 over 4 in the denominator, I'd be fine with that. But when you are given the equation of the asymptote, when they tell you the equation of the asymptote is, you can use that value to set it equal to either the a over the b or the b over the a, whichever one comes, whichever one you're using. Does that make sense? Yes? All right. One more thing I want to talk about. Now, this right here, classifying conics. We're not doing eccentricity and all that stuff, so just go down to the general equations of conics. Some people, first period, they're like, what's a conic? It's all the stuff we've been talking about. The 4 shapes, a circle, a parabola, an ellipse, and a hyperbola. All right, circles you guys are super familiar with. You need a center and a radius to write the equation of a circle. And a parabola, one of the variables is squared, one of them is not, depending upon, like that's not the only, obviously you can, God bless you, you're going to x minus h squared equals 4p, y minus k, or y minus k squared equals 4p, x minus h. And then you have your 2 ellipses and your hyperbolas. Again, what is the biggest difference between an ellipse and a hyperbola? Ellipse adds, hyperbola subtracts. All right, everything else is the same. So this general rule, if you're given an equation, like we're going to be in the next slide, and it says classify the conic, right? Figure out which one is which. This is saying is in an equation, and you'll see in a second, if your A value and your C value is the same and A is not 0, it's a circle. If your A times C is 0, then it's a parabola. If AC is greater than 0, then it's an ellipse. If it's less than 0, it's a hyperbola. But there's other ways you can do that. If you don't memorize that, that's totally fine. It's totally fine. If I look at this next slide, this is what I'm talking about. Classify the graph of each equation. First of all, there's only one of these that you can look at this and say, oh, this is definitely this. The rest of them, you got to think a little bit. But which one can I classify right now and say, oh, it's for sure a circle or a parabola or an ellipse or a hyperbola? Which one? Here, I'll tell you the answer. Number 1 is a definite. What do you know? Number 1 is definitely. Look at the variables. Why is it a parabola? Correct. In a parabola, guys, only one of the variables is squared, not both of them. Only one is squared, not both of them. So if all it says to do is classify, tell me what's what, okay, fine. Tell me what's what, and we're good to go. If it asks you to identify all this stuff, then you got to complete the square and all that. Now, if you don't memorize that little chart that I just showed you a second ago, you can complete the square with all of these. I'll do that. I'll work through the problems and I'll complete the square of all three of them so you guys can see how to do it. But if you do memorize what it says, all right, what is your A term and what is your C term in letter B? Tell me what A is and tell me what, this is A, correct? You guys agree? And this is your C term? Whatever's with the x squared and the y squared. Yeah? Do you guys understand that? Tell me, yes? All right, so if I were to look at, if I was going to multiply 4 times -1, what does that give me? -4. So what is the relationship between -4 and 0? -4 is what? Less than 0. So if you look at that little chart, what does that tell you? If A times C is less than 0, what is this? It's a hyperbola. Now, again, if you don't memorize that, not a big deal. Not a big deal. You can complete the square on all of them. But let's look at the next one. If I take my A, that's what's whatever with x squared. And I take my C, that's what whatever is with y squared. If I multiply those two, what is 2 times 4? It's 8. So now tell me the relationship between 8 and 0. 8 is greater than 0. So if you look at that little chart, what kind of a conic is this if you multiply A times C and your answer is, God bless you, greater than 0? It's an ellipse. All right, good. All right, now I'm going to take my A, that's whatever's with x squared. I'm going to take my C, that's whatever's with y squared. You guys with me? And I say, okay, 2 times 2. So 2 times 2 is what? 4. What's the relationship? 4 is what? Greater than 0. Now, oops, not 40. 4 is greater than 0. And you guys would tell me it's a what? It's an ellipse. It's actually not. And you're like, wait a second, huh? What does the chart say? If A is equal to C, well, in this case, guys, what is your A term? A. What is your C term? C. So this actually says 2 is equal to 2, correct? What is the process if your A and C are equal? This is a circle. I think this is a good thing to help you guide, but I think it's better to know how to complete the square, how to get all your terms together. I think that's your most important, your best bet, because most questions are going to ask you for more than just, hey, what is this? It's not going to say, here's 10 questions, tell me what it is. It's going to say, what's the focus? What's the A? What's the B? You know, that sort of a thing. So don't just rely on that chart, but understand what that chart means. It's the relationship between the A and the C values and 0. If A and C are the same, it's a parabola, it's a circle. If A and C equals 0, if you multiply A times C and it's 0, it's a parabola. But if you look, guys, if I look at the parabola, you're like, wait a second. There is no C term. So if there is no C term, if there is nothing with y squared, then what do you recognize that it is? It's 0. So you would say 4 times 0. You understand what I mean by that? Like, because your A term is what is with x squared, so it'd be 4. Your C term is whatever's with y squared. There isn't one. It's 0. That's why this is 4 times 0 is 0. That's why it's a parabola. Another way you can look at it is, oh, one of the variables is squared, the other one isn't. Does that make sense? All right, so